Hello viewers, I'm Kausalya. In this video, we are going to discuss about individual R, L and C. So the first topic is purely resistive circuit excited by a sinusoidal varying voltage. Here we are taking a resistor and the resistor is excited with a sinusoidal voltage. And now we are going to know the performance. So let V is equal to Vm sin omega t since we are giving a sinusoidal input voltage, right? So this is the standard or general representation of representing a sine wave. And R be the resistance of the circuit and I is the instantaneous current flowing in the circuit. You see, just look at this diagram, right? So V is nothing but that is Vm sin omega t. So this is the input sinusoidal voltage, right? And R is the resistance of the circuit and here I is the current that flows through this circuit, right? Now we are using Ohm's law, right? By Ohm's law, here V is equal to I into R. Therefore, I is nothing but V by R. So, what is the value of V here? V is nothing but, just now we have seen, right? It is Vm sin omega t. So, just substitute the values, right? Now, the next thing is, when the value of sin omega t becomes 1, right? I becomes Im. That is, it is the maximum value of the current when omega t becomes 1, right? Therefore, this is what I had written here. When sin omega t is equal to 1, then I becomes Im, right? So, I becomes Im and sin omega t becomes 1. Therefore, the remaining terms are Vm by R. Right. Now the value of R is given as Vm by Im. Right. Or simply we can write R is equal to V by I. Right. Now you see the value of I is, it is nothing but Im into sin omega t. Previously we have seen we are giving an input voltage V which is equal to Vm into sin omega t. Let this be equation number 1. Now, I is equal to Im into sin omega t, okay, in a resistive circuit. That is a circuit which has only resistance. So, when you compare equations 1 and 2, you see V is equal to Vm sin omega t and I is equal to Im sin omega t. What does it mean here? That is the voltage and current in a resistive circuit are in phase. Why we are saying it as in phase? Because here we are having sin omega t and here we are also having the same sin omega t. You see here there is no plus or minus pi, right? That is pi is absent here. What does it mean? V and I are in phase, right? So this is what represented in this diagram. That is they are in phase. They are together. There is no phase lag or phase lead between the voltages and current in a resistive circuit. Right. Next we will proceed with the inductive circuit. Circuit consisting of pure inductance excited by a sinusoidally varying voltage. That is, again consider a circuit. We are having a voltage source V and here we are having only inductor, right? And I is the current that flows through the circuit. Again, since we are applying a sinusoidal voltage, here V is nothing but Vm into sin omega t, right? And E is nothing but it is the voltage across this inductor. So, voltage across the inductor is given by E is equal to minus L into di by dt. Right, this is a formula. Voltage across the inductor is given by this formula. And the next thing is by Lenz's law, right, this voltage, that is voltage induced across the inductor, it opposes the applied voltage. Therefore, here the applied voltage is V, right? Therefore, E is written as minus of V because the voltage across the inductor opposes the supply voltage, right? They are opposite. Therefore, E is equal to minus V. Now, let this be equation number 1 and let this be equation number 2, right? Both are nothing but E. Therefore, we are equating equations 1 and 2. So, that gives the answer as minus v is equal to minus L into di by dt. So once you solve, it is given as v is equal to L into di by dt and di by dt is equal to v by L. Now we want only, that is we are calculating the current that flows. Therefore di is equal to 1 by L into v into dt, right? This dt comes to this side as a numerator part. Next we need I. So we are integrating. So when you integrate, di becomes I 1 by L integral of v into dt, right? So what is the value of v? V is nothing but Vm into sine omega t into dt. Now when you integrate this term, you see it becomes minus cos of omega t divided by omega, and this L comes here, right? And again, just when you rearrange, we are having Vm by omega L into minus cos omega t. So this cos omega t is written as sine of 90 minus theta, right? This minus sign comes in the previous step also, so write this minus as such. So cos of omega t is written as sine of 90 minus omega t. Now you see Vm by omega L into, that is we are pi by 2 minus omega t, we are rearranging, okay? So there will be a minus sign again, right? Because we are reversing these two things. That is minus omega t becomes plus and this plus pi by 2 becomes minus. So there will be a minus sign. You have to take a minus sign outside. So minus into minus, that becomes plus here, right? So sine of omega t minus pi by 2. So what happens? Again the same thing. When this expression is equal to 1, right? I is equal to I max. So what happens? When you make this expression as 1, I becomes I max. Therefore, I max is equal to Vm by XL. So, that is omega L is rewritten as XL. So, I is nothing but, you see, when you rearrange again, XL is nothing but Vm by I max. And here, I is nothing but, right, Im into sine of omega t minus pi by 2. Now, this is your expression for current, and you see this is our expression for voltage, V equal to Vm sin omega t. Now when you compare the voltage and current, so when you compare the voltage and current here, you see here it is sin omega t, whereas here it is sin omega t minus pi by 2. Okay, there is some other angle here. So from these expressions we can conclude that, you see, the current lags behind the voltage by pi by 2. So this is the current. So this lags behind this voltage by how much angle? By this angle of pi by 2 here. So pi by 2 is nothing but 90 degrees. So when you draw the diagram of voltage and current, you see this is your voltage and this current lags the voltage by 90 degrees, right? So now we are going to proceed with the capacitive circuit. Pure capacitive circuit excited by sinusoidally varying voltage. So again here the same case, we are having a capacitor and the input voltage is a sinusoidal voltage and I is the current that flows through the circuit, right? So the value of I is given by dq by dt. So this is a general expression. So here Q is nothing but C into V. So when you replace this Q by CV, you see C into dV by dt. Even I can write one more step here. You see d by dt of Q is nothing but C into V. Right. Now C is, the value of C is a constant because the value of capacitor is fixed, right? So here we can take C outside and the remaining terms will be dV by dt. And again V is nothing but Vm into sine omega t. Now we have to differentiate. So once you differentiate, you see Vm into, that is sine omega t becomes cos omega t, and again here we are having a omega t. When you differentiate, that becomes omega, right? So when you combine the values, you see Vm into this Vm here and sine omega t differentiated becomes cos omega t, right? And again when you differentiate this omega t, that becomes omega and this C comes here, right? Now Again, this cos theta is, we are rewriting, okay, cos theta as sine of 90 plus theta, right? Now we are writing this omega c as 1 by omega c in the denominator part. Now 1 by omega c is nothing but it is xc, right? So again, I becomes Im when this expression becomes 1. So I is equal to Im when this expression is equal to 1 here. So when you substitute, you see I becomes Im, so Vm by Xc, and this value becomes 1. This is what I had written here, right? So finally Im is equal to Vm by Xc. So Xc is nothing but Vm by Im, or simply we are writing it as V by I. Now what is the expression for I? This is your expression for I. What is the expression for voltage? It is nothing but Vm into sine of omega t. Right, when you compare these two expressions again, you see here there is an angle of pi by 2. So what does this pi by 2 mean? That is, the current leads the voltage by pi by 2. So the diagram is like this. Here we are having a voltage, here we are having a plus pi by 2. Therefore the current leads, okay, leads the voltage by an angle of pi by 2 here. So here comes the end of this video. So this is a basic introduction about how the values of voltage and current, that is either they will be in phase or out of phase. If they are in out of phase, then by how much angle, okay, for a purely resistive circuit, purely inductive circuit, and purely capacitive circuit. So this forms the basic of solving problems. So if you have any doubt, let me know in the comment section. Thank you.